So let us continue now the isomerism in complex compounds. You have completed isomerism in coordination number 4, geometrical isomerism in coordination number 4, that is tetrahedral geometry and the square planar we have taken. Tetrahedral geometries cannot exhibit geometrical isomerism we discussed, and only scale planar geometries exhibit geometrical isomerism. Different types under scale planar geometry with monodentate ligands and also bidentate ligands. We thoroughly discussed different models I shown on the board. Next, today we will discuss same geometrical isomerism with coordination number 6 and octahedral geometry. Geometrical isomerism with coordination number 6, octahedral geometry. Geometrical isomerism in octahedral geometry. Octahedral geometry. Now, under this types, let us say, we will take now first with monodentate ligands. With monodentate ligands. Take the first one, MA6 plus or minus N, MA5B plus or minus N, no geometrical isomerism. Look here, all the 6 ligands are same or 5 ligands are same. We cannot write any second structure or second geometry for that particular complex. Therefore, in octahedral geometry, all the 6 or 5 ligands are same. Such complex cannot exhibit any geometrical isomerism. So, here no geometrical isomerism. No geometrical isomerism. Coming to the second one, there should be at least 2 ligands different. So, what are the types you see now? MA4 B2 plus or minus N, MA4 BC plus or minus N, MA3 B3 plus or minus N, MA2 B2 C2 plus or minus N, MA4 B2, MA4 BC, MA3 B3, MA2 B2 C2. Next, you can also take MA2 BC DE plus or minus N. Next, MA B C D E F. So all the 6 ligands are different from each other. All these complexes, all these models exhibit geometrical isomerism. All exhibit geometrical isomerism. Exhibit geometrical isomerism. Let us see one by one all these different types. We will take the real complex. We will discuss how they are exhibiting geometrical isomerism. Take the first one, MA4 B2 plus or minus N. See, 4 ligands are of one type, 2 ligands are of the other type. So, this we can write, say one complex, whatever you know this, take CO taken 4 times, Cl2, MA4 B2 plus. You can write cis and trans, look the board, octahedral geometry, make octahedral geometry. Right, 2 chloro ligands are writing cis to each other, adjacent. Remaining 4 ligands, So this particular complex we consider what a cis. Cis. Then one more I write trans. We'll keep this particular chloride ligand in the axial position. This you consider as what trans. Cis complex and trans complex, two complexes. That is what these two are geometrical isomers to each other. You can also take next one, Ma4B2 I written now. You can take Ma4BC. Keeping the two different ligands, let us consider simply one is chloride, one is bromide.